Hi kids, time for the law of cosines. As a review, our goal has been to solve triangles. And remember what that means is you're finding the length of three sides and the measure of three angles. Using given information, right? You have to have given some information. So we have dealt with non-right triangles and right triangles. I don't know why I have an apostrophe there. So for right triangles, we can use Pythagoras, and we can use our right triangle trig, right? Like our SOHCAHTOA. Non-right triangles, we can use the law of sines, or we can use the law of cosines. So obviously, when do I use Pythagoras or the right triangle trig? It's when I have a right triangle. The law of sines or the law of cosines is when I have non-right. So I need to remember, when did I use the law of sines? We used the law of sines when we had two angles and a side in between them, or we had two angles and a not included side. And then remember, we had the special two sides and the non-included angle, right? And that was our ambiguous case. So that one took the most work. So what's the law of cosines for? Law of cosines is if you have all three sides, or if you have two sides and an angle in between, right? So that's kind of how I organize my thoughts when I go about trying to decide, how do I solve this particular triangle? So I'm going to give you the formula for the law of cosines. Right? Again, I'm dealing with side, 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 or side, angle, side. There's the law of cosines. Take a look at what's on the left side of the equation and the far right side of the equation. They match, right? So it doesn't really matter what letters, but whatever side I have here, I have to have the cosine of the angle opposite over here. And then you have your other two sides that you're squaring and adding together, and your other two sides that you are multiplying together and also times -2. Okay? And then, of course, the cosine of the angle. Now, check this out. What if I gave you that angle A is 90 degrees? Look at what happens to that equation, right? What's the cosine of 90? Cosine of 90 degrees is 0. 0 times I don't care is 0, and look what you have left. Because one of your angles there would be a right angle. Right? And if this is angle A, the side opposite is the hypotenuse. Right? So that's what that says. Pretty cool. So here's a random non-right triangle. There's angle A, opposite side A. So if you know this angle and you know C and you know B, you have the side angle side situation, and you are going to put A squared on the left. You're going to square C, square B, add them together. Since it is addition, it doesn't matter the order. You're going to take B and C, multiply them together. Again, because multiplication is commutative, it doesn't matter the order. And then you're going to subtract from this sum 2 times this product of side, side, cosine of the included angle. Conversely, if you have, that's for side angle side. If you don't have side angle side, you don't know the angle, let's say, you only have side, 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 well, then you're going to be filling in a number here, 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 and here, and you're going to solve for the included angle, And of course, you're going to have to use inverse cosine in your calculator there. All right. Don't forget to line up your included angle with the opposite side, and that's what goes on the extremes of the equation. This side squared goes on the far left. The cosine of that included angle goes on the far right. So let's try this example. First, identify the situation you have. They've given you the included angle, and you have two sides. So this is the side angle side situation. This time, C is the angle I was given, and it, of course, is across from side C. So since I have side angle side, I'm going to use the law of cosines. The given angle goes here, which means the side across from that given angle goes here. 9 and 7 go here. It doesn't matter the order. It doesn't matter the order. Now I'm solving for C. So I'm going to undo. Now really, right, undoing a square is a positive and negative square root. But since I'm dealing with the side of a triangle, I only need the positive, right? Because it is a physical length of a triangle. Okay, so there we go. Now I'm just plugging and chugging this into my calculator. And when I plug this into my calculator, I get 5.79. Again, reasonable. If you said 5.8, that's also reasonable. Now what? I found the length of C, 5.79. And now I need to find these other two angles. But now I have three sides. I could use the law of cosines again, but I could also do the law of sines. Right? And sometimes this ratio is a little bit nicer to work with, but you don't have to. It doesn't matter. I'll be able to follow your work. So sine of 40 degrees, oh, I should have a degrees on, shouldn't I? Sine of 40 degrees compared to 5.79 is the same as the sine of A compared to 9. And I got 89, not exactly, 89.0 degrees. And then I used my triangle relationship of 180 minus that sum to get B. If you just put 51, I'm fine. If you just put 89, I'm fine. Okay, done. Right? Not so bad. So I'm skipping example 2 because we'll do example 2 in our live session. But I want to throw you a little bit of a curveball. What situation do I have here? Side, 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 right? Three sides means do the law of cosines. So there's me setting up the law of cosines. So notice that I picked, right? I have three sides, so it doesn't matter which side I decided to start with. But since I chose 8, that mandates then that angle A be on the end. If you had chosen 9, C would go on the cosine of C. If you had chosen 15, cosine B would be at the end. So notice this time, though, I am solving for cosine. And I got 26.3, right? So now be careful with your algebra here. Please be careful, right? What are you doing to get cosine of A by itself? You have 8 squared minus what? right? You're subtracting both of those. Then you are dividing by that product. That is equal to cosine of A. And then you're doing inverse cosine of both sides. Okay, notice I have a negative in the denominator, but I'm also going to have a negative up here. All right, and when I was done plugging and chugging all of that, I got 26.3 degrees. I'm going to use my law of sines, just like I did before. And I said the sine of the angle that I got before compared to its opposite side would be 8 is equal to sine of B. So I'm looking for B compared to its length. And I got 56.3 degrees. One more time. Using my triangle relationship with 180 degrees, I got 97.4. Everything looks swell. Pretty happy with myself, feeling pretty good. But there's something wrong. Can you see what it is? I didn't make a math error. Anyone? Anyone? What do you think? What's wrong here? Remember what I told you in the last lesson? Always double check. Where's my largest angle between A, B, and C? Who's my largest angle? C. Your largest angle has to be across from your largest side. That's not right. Oh no. Right? What happens? So really what happened was that every time this had to do with the fact of when I was solving, it has to do with where your inverse relationships are. Remember when you were solving for B here, you were using inverse sine, and inverse sine is only going to give you an angle between zero, is going to give you an acute answer, right? So I have to know that really using my calculator, you have to think. Your calculator does not think. So the law of sines can sometimes let you down, which is why the law of cosines is a little bit hairier to do and it's a little nastier of an equation, but you're going to get the real answer for cosine of B. Sorry. Because inverse cosine is defined in quadrants 1 and 2. So when I did this, I got B to be 123. So yes, A was 26.3, but B was actually 123.7 degrees, and C ended up being 29.9 degrees. And now check, does your largest angle match with your largest side? So what's my lesson here? My lesson is be careful with anytime you're using inverse trig in your calculator, you have to think about, does that make sense, right? Or at least know the kind of answers you might get, and then make sure you check your triangle when you're done. Or here's another way to try to avoid that situation. If you always notice that when I did the law of sines, I chose 8, right? I could have put, because I have side, side, side situation, I could have chosen any situation to start with. Maybe I should have started here. When you're doing side, 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 if you start with the largest side, here, I would have gotten 123.7 right away. I would have checked, yep, that's a go, right? And then my law of sines, I would have been more apparent as I was going along. All right. Cool. All right, so that's it. Again, in our live session, we'll go through another law of cosines example with you, and we'll do some warm-ups. And I will see you then.